The second rule for differentiation is one which most students consider to be their favorite of all the rules. It's the power rule, okay? So what we're looking at is we have x to some power, okay? Let's pick the first example that we did a long, long time ago, okay? We had f of x is equal to x cubed. And if you go back and you check out your notes from that, when we watched that video and you did the work through on your note sheets, you saw that f prime of x was 3x squared. Okay, so look at what we started with, x cubed, and look at what our derivative ended up being. Can you see some kind of shift happening with the exponent? That's what the power rule is taking. It says, hey, if you've got a cubic function and you're going to derive it, that exponent, that 3, is going to move out in front of your variable. And the exponent will then drop down 1 unit. Okay? And this works for any value for your exponent, any number. Okay? So if we have x to the nth power, okay, what's happening is the n comes down in front of the x. So we have n times x, and then we subtract 1 from the exponent. So our new exponent is n minus 1. So let's do a couple of examples with this. Okay, let's say that we have y equals x to the 8th power. Okay, we want to find the derivative of that. So that's dy dx. What does dy dx equal? Separate here. Okay, well, the rule states we take our exponent and we move it out in front of the variable. So we're going to have 8x. Okay, and then we subtract 1 from our exponent. The exponent was 8. So now it's 7, and we're done. That's it. That's your power rule. Let's do another one. What if the power was negative? All right, let's say we have g of x is equal to x to the negative 3 power. All right, we think, well, what's a negative exponent? So think back to algebra. A negative exponent was positive if it's moved down into the denominator. So this is basically asking for the derivative of the function 1 over x cubed. But we're going to use it in this format because this format allows us to do the power rule. N matches with the negative 3. So let's do our derivative. G prime of x equals, here we go. Bring the exponent out front. So negative 3 moves in front of the x. And then subtract 1 from the exponent. Here's where you got to be careful. Negative 3 minus 1. Some students want to say, oh, that's negative 2. 3 minus 1 is 2. But be careful, it's negative 3. Negative 3 minus 1 is negative 4. Okay, so we have an answer of negative 3x to the negative 4th. That's our derivative. And that's a perfectly fine way to write the derivative. But just keep in mind, from algebra again, that this can also be written as a fraction, like this one up here. Negative exponents become positive when they're moved down into the denominator. So we can take that x to the negative 4 and move it down into the denominator. The negative 4 doesn't belong to this coefficient of negative 3. So that negative 3 does not move down into the denominator. It stays in the numerator. Again, both of those answers are fine. It's easier to get our answer by working with the negative exponents. But you want to just be ready to go back and forth between a negative exponent and a positive exponent that has been moved down into the denominator. Let's do one more. What about the square root of x? We just took a look at that video a little while ago. All right, we make h of x equal to the square root of x. Okay, well, another way to write the square root of x, from your algebra class, we know that radicals can be changed into rational exponents. This is the square root of x to the first power. So we know that this is the same thing as x to the 1/2 power. Okay. Well, it doesn't matter if the exponent's a fraction, we can still do our power rule. Let's get our derivative. H prime of x, we take our exponent and we move it out front. So the 1/2 moves out front. Then we write our variable again. And now it's to the 1 less power. What is 1/2 minus 1? All right, 1/2 minus 1 we know is 1/2 minus 2/2. 1/2 minus 2/2 is negative 1/2. There's our new exponent, negative 1/2. That's our derivative, 1/2 x to the negative 1/2. Let's rewrite this one as well. We can do that rather quickly using our algebra skills. Okay, we have a fraction, 1/2, right? And then we have x, but it's a negative exponent, which means, just like before, we can make the exponent positive as long as we move it down into the denominator. So we have x to the positive 1/2. Okay, but x to the 1/2 is the same thing as the square root of x. So let me rewrite that in as well. So I have 1/2 times the square root of x. Look how quickly and easily we got that derivative. If you check back a couple videos ago, we found the derivative of the square root of x. We had to do it out the long way. It took a lot of work with our radicals. It also took the whole definition of the derivative. It took a lot of time and effort. This was much quicker and just as valid. So while we do have the old derivative, and we don't want to forget that derivative definition, when you're actually finding the derivative, we want to use the rules. It's so much quicker.